Hey everybody, welcome to the Unit 1 review. In this video I'm going to do everything on the left side that's labeled we do, and then I want you to work on the problems that say I do. So getting started here, the first two problems are just solving systems of equations. You can choose to solve it by hand if you want. I'm going to use the calculator because this is a multiple choice test and there are no questions on it that specifically say use substitution and show your work. So if it doesn't say that and you'd rather use a calculator, then why not? So I'm going to convert this to a matrix since that's what we went over. You could also use the linear solver, the menu 3-2, and just type in the equations as they appear and you'd also get the solution. But since matrix was the focus of Unit 1, then I'm going to do that. I'm going to convert these to a matrix. So remember, to be a matrix, things need to be in standard form, and you need to use these four letters R, R, E, F. So you have R, R, E, F, and then you have to put the parentheses, and then you're going to convert it to a matrix by just using the coefficients that go with the letters. So, and they should go in order, X, Y, Z equals. So the first one's good. It goes 5. I have negative 1y, 7, and 16. The second one looks good too. It has 1x, 1y, negative 2z, and negative 5. I'm never going to write the letters, but everything needs to go x, y, z. So the third problem, has a 10x, but then the 2y minus 14, they're out of place. So let's minus 2y over, and let's add 14z over to get it to the other side. So if things are out of order, you know how to put them in order. Just add or subtract them to the other side of the equal sign. And so we get 10x minus 2y plus 14z, and we left behind the 8, so equals 8. So I'm going to write a 10, a negative 2, a 14, and a positive 8. All right, so there's my bracket. I'll close the parentheses, and you'll type this into the calculator. You know, you'll size it as a 3x4 equation, or matrix, I should say, and type it in, and let's see what the output matrix is going to look like. Okay, so when you type it in, this is our output matrix. And no, we didn't do anything wrong. This one's actually a special case, and that's because the answer is no solution. And here's how you can tell that. You get something weird in your matrix, but that last row, 0, 0, 0, 1, if it ends up looking like that, that means it's no solution, okay? So I do let you use a note card on the test. You might want to write that down on your note card, that's what a no solution matrix will look like. And if you use the linear solver, the menu 3-2, I won't feature it in this video, but it actually does say no solution found once you type in the equations. So yeah, just letting you know. The next problem, you see the top equation is not in standard form. So if I plus this x over, it will be in standard form. So I'm ready to convert this to a matrix now. So I'm going to write down R, R, E, F. I'll put parentheses, I'll put my bracket, and then I have 1x, 1y, 1z equals 8. I have 3x minus 1y plus 4z equals 25. I have 6x minus 2y plus 8z equals 50. All right, so type that in. It's another 3x4 matrix. And let's take a look at our output matrix. So once again, our output matrix looks kind of weird, but turn your attention to the bottom row again. You have all zeros. So that one's actually going to be infinitely many solutions. So if you have all zeros and a 1, no solution, all zeros and just all zeros. Infinitely many. If you use the linear solver, the Mini 3.2, you get this really weird looking answer, but it doesn't specifically say infinitely many solutions. It just looks really weird. So yeah. All right, number 3 and 4, we're going to read it, and then we're just going to write our equations. We're not even going to solve it. The Garza family enrolled their 4-year-old, 3-year-old, and an infant in daycare for $2,800 a month. The Martinez family enrolled their 4-year-old and twin 3-year-olds in the same daycare for $2,650 a month. The Richards family spends $3,000 a month for their 3-year-old and twin infants to attend. Define your variables and write a system of equations that could be used to solve the situation. All right, so what are my variables here? It's not super clear because it's not asking like a question at the end, and usually the question says it. But what are we changing with each family? We're changing the kind of kids. So you got a 4-year-old, a 3-year-old, and an infant, a 4-year-old, 3-year-olds, and then you have a 3-year-old and infants. So you have 3 types of kids. You got X can be the number of 4-year-olds, and Y can be the number of 3-year-olds, and Z can be the number of infants. All right, so that being said, let's just make our equations. How many 4-year-olds did the Garza family have? They had 1 4-year-old, so I'm going to write 1x plus a 3-year-old, 1y, and an infant. So 1z equals 2,800. All right, let's do the next family. The Martinez family has a 4-year-old, x, twin 3-year-olds, so that's 2y, and they have no infants. So you can throw in a plus 0, z, or you can just make it equal what it's supposed to equal. Since we're not solving it, we don't have to throw in a 0z. So they're going to spend $2,650. And then the last family has a 3-year-old and twin infants. So they have 0 x's. So they have 1 3-year-old, 1 y, and twin infants, 2 z equals 3,000. And really that's all there is to it. So let's just move on to number 4. A local radio station hosts a pool party where they promote their station by giving out free concert tickets and baseball caps. They are permitted to distribute up to 100 items, and they expect to give away at least 10 concert tickets and 50 baseball caps. Write a system of inequalities that could represent the possible combination of items given away. All right, so this one's kind of tricky because it's inequality writing. Let's see, what do we have control over? Those will be our variables. We have control over the concert tickets and the baseball caps. So, X can be the number of concert tickets and Y can be the number of baseball caps. It says they're permitted to distribute up to 100 items. So if I say X plus Y, this is an inequality, so don't say equals 100. You can distribute 100 or less, up to. So that's going to be less than or equals to 100. And then the next one says they're expected to give away at least 10 concert tickets and 50 baseball caps. So I'll write at least 10 concert tickets, so that was X. So X is going to be greater than or equal to 10. And then Y will be greater than or equal to 50. So we actually have 3 equations here for 2 variables. It happens sometimes, or 3 inequalities, I should say, not equations. But yeah, at least 10 and at least 50, it would make those 2 down there, and that's all I have to say. Let's move on to number 5. We're going to graph this system of inequalities. So the first one, X is greater than or equal to -3. I'll do it in black. Just go to -3 on the x-axis. Draw a solid line because it was underlined. Look how good that line is. And then which way is it going to shade? The arrow points. Greater than would be to the right, so I'm going to just shade to the right. And then I'll move on to the next one. I'll do it in red. And so I start at +4, that's my y-intercept, And 1, 2, 3, 4, put a dot. And then what's my slope? Negative 1 over 3. So I'll go down 1 over 3, down 1 over 3, and then I can also go back 1 and left 3 for a couple of points just to draw a good line. So am I going to connect this with a solid or dashed line? Looks like it's going to be a solid line because it's an underlined inequality symbol. So there's a poorly drawn solid line. And which way am I going to shade? I'm going to shade below the line because it was less than. So below. And then I can move on to y is greater than x. So a y is greater than x is just, you have a 0 slope, or 0 for the y-intercept because there's no y-intercept. So you'll start here. And then your slope is a 1 in front of the x, 1 over 1. So you'll just be going like this. And it's a dashed line because it's not underlined. So I'll dash through these. And then it said it was greater than, right? So I'll shade up. And then it looks like this little triangle right here is my common shaded area. That's where I see red, black, and blue right there. So yeah, that's all there is to number 5. Number 6 says identify 3 possible solutions. So we are looking at this triple common shaded area and just pick 3 points that reside in it. So how about this point? That is 0, 2. How about this point? And then just so we're clear, you could pick something on a solid line. So something like this right here. So I wrote down 0, 2 for the first one. And the second one goes left 2, up 3, so negative 2, positive 3. There's a whole bunch of answers for this. It's just pick any that would work. And then I went negative 3, or positive 3, I should say. Negative 3, positive 3. All right, and then number 7 says write a coordinate that's not a solution. So not a solution would be anything outside this common area, such as this point right here, this point here, there, wherever. Just to make a point about it landing on a dashed line, I'm going to choose that because dashed line you can't touch. So I'm going to write 1, 1. But yeah, there's literally an infinite number of answers for these. So 1, 1 it is. And yeah, let's move on to number 8. Write a system of linear inequalities to represent the graph below. So we got this vertical line right here. What's going on? It's going through the x-axis at 1, 2, 3, 4, and the shading's to the right of it. So I'll put an X, put the arrow to the right, and put a 4. I'm not going to underline it because it's a dashed line, so that's all that one is. Let's see here. This one right here, what's the y-intercept? It starts right there. So that was up at 3, so I'll put a plus 3. And then what's my slope here? So I went up 1, 2, over 1, where it's going through the corners. Yeah, it looks like it's positive 2 over 1. So I'll just put a 2x. You could put 2 over 1 if you wanted, but I'm just going to write it 2. And the shading is going to the left of it. That's on top of this line. So that's going to be a greater than symbol. And it's not going to be underlined because it's a dashed line. And then the very third one, the very last one, starts at 0. And what's the slope here? So it looks like it's going down 1 over 2. So negative 1 over 2 would be my slope. So I'll start at 0. I can write plus 0 if you want, and write down 1 over 2x. Where's the shading? The shading is on top of it this time, and it's a solid line. So if the shading is on top, it'll still be greater than, but it's going to be greater than or equal to because it's a solid line. So I have y is greater than or equal to negative 1/2 x. And I'm just going to erase the plus 0 because if it starts at 0, you don't normally write the plus 0. So yeah, those are my 3 inequalities to match the graph. Look for the slope, y-intercept, and the shading. Other than that, thank you for watching. Good luck on your tests. Make sure to put any notes you want on your note card, and goodbye.